Hi, this is Adam from MakerState, and I'm here with the webinar for Scratch Science, Food, and Energy. To deliver this challenge, you're going to need charged computers with internet access, your printed rubrics and parent reports, and your design cycle poster and badges. And you can find these printable materials as well as other resources for your classroom on the STEM Collab. Here you can find the lesson plan, which provides step-by-step instructions, and then the rubric, the Scratch project prototype, which is my prototype, and the challenge report, all here on the STEM Collab. And under that, you have the create video, where you can see me walking through how to build this project. Okay, so those were our materials. As we look into the discover phase, this challenge is about energy and food and conceptualizing those things in video games and thinking about health and energy, right? So here's some opening group discussion questions that we can pose to our students to get them to start talking and thinking about these ideas. What is energy? What are some sources of energy? How do humans get our energy? And have you ever played a video game or some other sort of media or game where a character has to collect food in order to gain health or energy? And some examples that I can think of that come to mind are Super Mario Brothers, where Mario collects mushrooms to gain strength, or Pac-Man, where Pac-Man runs around collecting fruit to gain points, or there are many other games where collecting food for health or for energy or for strength or power-ups is an important part of the game. Okay? And after you have some discussion around that, you can move towards your STEM idea and keywords. In our STEM idea, how can we create a Scratch program that demonstrates how people and animals get their energy from food? And keywords are energy, the ability to do work, the ability to move and exert effort, right? Transfer of energy, and this is just the idea that energy is never created or destroyed, rather it just transfers between different forms and between different objects or beings or animals or other entities, right? And in this case of food and energy, we're talking about energy stored as chemical energy in food, and then we transfer that into kinetic energy. We as people transfer that into kinetic energy as we move and do things with that energy that we get from food. Okay, and finally is our final keyword is a loop. And a loop, is something maybe your students are already somewhat familiar with if they've been programming in Scratch, but it comes up a lot in this program. And in this program, we even have loops inside of loops, which we call nested loops. But just thinking about loops and how they can be used to create, powerful and efficient programs is something that, you want to keep in your mind as you're going through this challenge. Okay, and after that, you can show your Scratch prototype and introduce the general build process, highlight the use of variables as well as looks blocks, as they both come up a lot in this project. We're using looks blocks to control the size of sprites, and we're using variables to store an energy value, which affects other parts of the simulation. Okay, and if we go over here to our food and energy project, we can take a quick look at some of those things. Let's just see how this project runs once more. So by default, whoops, it's running really slowly right now. Let me close something quickly. Sometimes my computer bugs out a little bit when I record videos while I'm running Scratch. But okay, here, this looks like it's running well. And my energy has gone down to 2. And now it's gone down to 1, which means I'm moving very slowly. But you'll see when I get to these bananas, now I speed up quite a bit. And the bananas start to grow back. And if I eat more bananas, I speed up even more. My energy goes up to 9, and now it's down to 8. And so this energy value is falling over time, so I have to continually eat bananas to sustain my energy. And if we let my energy get too low, the cat will tell the user, the player, hey, I'm getting really tired, I need some energy. Let's wait till that happens. Here, I'm tired, I need some food. Okay, great. So let's look at the code really quickly. Over here, we're in the cats code, and there's 2 main pieces of code that are happening here. On this left side, we have the movement code, which is all you should be relatively familiar from other sorts of projects that you might have programmed. I'll stop this now. We have just key right arrow and key left arrow, basically 2 identical if-then statements. Just one is pointing us in the right, pointing us to the right positive 90, and one is pointing us to the left with negative 90, and we are moving energy steps. So whatever our value of energy is, that's how many steps we will move, and then using the next costume to get that little walking animation, okay? The other piece of code for the cat is kind of monitoring the energy of the cat. So we start by setting it to 5, and then every 3 seconds, if the cat's energy is greater than 1, we subtract 1 from the energy level. And the reason we have this greater than block here is we don't want the cat's energy to get to 0, because if the cat's energy gets to 0, then the cat won't be able to move at all. And maybe there's situations where we want that to happen, and maybe we'll explore some of that in the improve phase. But for now, we don't want our cat's energy getting below 1. So if energy is greater than 1, that means energy can be at the least 2. And then when it gets changed by -1, then it will go down to 1 as our minimum value, okay? And when our energy is less than 4, we say, I'm tired, I need some food. We're just using a say block for that. And here using greater than and less than blocks from operators to achieve this. And that's our script for the cat. For the bananas, we just have one piece of code here, or one chain, and we have 2 loops inside of this main forever loop here, or we have 2 loops, I should say, total. This repeat loop nested inside of this forever loop, and here you can see us using those purple set size and change size blocks to control the size of the bananas. And how this script works is, when this begins, the banana goes set size to 0, which effectively hides it, and then waits 2 seconds, and then 10 times it's going to grow by 10% and wait half a second each time. So that means this will take 5 seconds total to go from 0, or really take 7 seconds total to go from 0 to fully grown. 5 seconds of growth and 2 seconds of initial kind of waiting period here. That's 0.5 times 10 to get that 5 seconds. And then we're waiting until the sprite touches the cat, and then we will change the energy value by 5. We will add 5 to the cat's energy every time the banana gets eaten and disappears. Okay? So that's the sprite for the cat, for the bananas, excuse me. And then the sun is just doing this very simple, growing and shrinking between 100 and 95%, separated by a second each time. And that's not, really affecting anything else in the program. It's just a nice aesthetic touch. And that's about it. I don't think our palm tree has any code associated with it. Nope. So that's all the code for this project. So after your students finish building that, they'll move into the improve section. And in the improve section, they'll start by playtesting. And here's some guiding questions for playtesting. Is there an energy variable that controls the sprite's speed? Is there a food sprite or a fruit or a vegetable that can be eaten and will grow back afterwards? And then did the engineer do anything to go above and beyond, the challenge requirements, or customize their project? Or are there any bugs or unexpected behaviors that need to be fixed or considered, right? So these are all some questions that your students can ask as they're playtesting. Remember, playtesting, you can do that in either pairs, in sort of a think, pair, share pair playtest, or as a gallery walk, where you have students walk around and playtest several projects. Whichever one you choose, make sure to use some paper or some Post-its to record feedback from your playtesters that your engineers can use to later iterate upon their projects. And after you playtest, you should have some time to iterate and improve upon, for your students to iterate and improve upon their prototypes. And here are a couple of prompts for that. You can either add other fruits or vegetables. So right now we have bananas. It'd be pretty easy to add another fruit or vegetable. We can do that just by kind of copying the whole sprite and just changing the costume associated with it. We could try to gamify this and turn this maybe into sort of a Pac-Man-esque or some other sort of game where players must continually sustain their food levels and sustain their energy levels in order to finish the game. Or finally, you can add costumes to your growing fruit and try to more realistically, visualize that growth process for fruits by editing some costumes or adding some of your own costumes. Okay, so let's go try some of these over in the Scratch project. And I'm actually going to start with this last one first, changing some costumes to make the growth process a little more interesting. And first, I'm going to just save this as a copy so I don't mess up my original. Oh, it might have already been a copy. That's okay. I'll save it as a copy. Anyway, And what I'm going to do with these bananas is I'm going to go to costumes and just do a really simple trick. I'm going to duplicate these costumes with a control click. You see that again in Scratch 3.0, there is no duplicate tool anymore. You just have to control click and then copy and paste. Now I have my green bananas, and I'm going to fill these bananas with a green color. You see I'm just clicking on this fill box here and picking my color. And once I have the color I like, then I can go to my fill bucket and fill away. There we go. So now I have my greened bananas. And if I go back to my bananas, to my banana code, I'm just going to add 2 blocks to this. My switch costume blocks, one for bananas and one for bananas 2. I could also use a next costume block, I suppose, because I only have 2 costumes, but this is a little more direct. So bananas is yellow, bananas 2 is green, and this is going to work such that the bananas switch to green when they disappear, and then when they're done growing, they can switch back to being yellow. Let's see that in action. So my bananas are green, and they're growing over time. We can see over here. And then once they finish growing, they become ripe, and then they're yellow. And if I eat one again, it will go back to being green and start growing until it becomes yellow. And then I can eat it. Okay? So that was a really quick and dirty, one costume edit that already makes this a little bit more realistic. And, you could very well go further with that. And if you wanted to, depict a different fruit, maybe something that grew on a vine or in the ground, I think would work really well for this, to draw multiple different costumes and show the change over time. And that's something that you can explore and try out. Okay? So next, I want to take a few minutes to try to gamify this and turn this into somewhat of a Pac-Man scenario, where my sprite must, collect food in order to reach it to the end of the maze, right? So I'm going to start by creating a new backdrop. I'm going to paint a backdrop. I'm going to use bitmap editing for this. I think it will be a little bit easier, and I'm going to pick sort of a yellowish, brownish color to start off to represent the ground. Okay, that looks pretty good. We filled that, and now I'm actually going to do this as a sprite. I'm going to paint a new sprite that is just comprised of some different walls. I'm still going to do this in bitmap, and now I'm going to take a sort of gray color and start just creating some walls. There we go. And I'm going to try to do this all in the same sprite if possible. Let's see if this is working. If I move this over, yeah, this appears to be working. Maybe I'll have to enlarge it a little bit when I'm done. Let's back out of there a little bit, and I'm going to draw one more down here. And I'm actually just going to use this edit tool to pop this up a little bit like so. Great. And maybe I'll shrink this whole thing a little bit, actually. Let's make this a size 90. Oops. How does that look? Not quite far enough. Okay, we'll keep it at 100. I think that'll work just fine. Okay, so I've created some walls for a... whoops, wrong thing. I've created some walls for a little maze here. I've positioned them on my stage like so. And now I'm going to hide this energy down here. And now we're going to work with our sprites. And the first thing I'm going to do is take this tree and shrink it down. Right now it's at a size 110. Let's make it a size 30. Much smaller. I'm also going to hide this sun. Okay. I have my palm tree at a size 130. I'm going to duplicate it 3 times. So from this menu, duplicate. And duplicate. Great. Now I'm going to do the same thing for the bananas. I'm going to shrink them down to maybe a size 40. And where'd they go? I can't see them, so I'm just going to send them to 0, 0 quickly. You underneath there? Yep. Okay. Good. And I'm going to do the same thing with the bananas. There's one bunch. There are 2 bunches. Whoops, down here. And here are 3 bunches of bananas. And now I'm going to do the same thing with my cat. So my cat right now is at a size 100. Let's make it a size 40. I'm going to bring the cat up here. And I'm going to quickly write some new... Well, let's see how this works so far. So we don't have much game mechanic yet, but we're running around, and I can collect... Oh, those bananas are still growing to their original size. So what I actually need to do is go back to this code, and instead of having them grow by 10, maybe I'll have them grow by 4 each time. That should bring them to 40% of their original size. Let's try that again. There they are. And now I can eat them, and that's good. Oh, but my cat can't go down yet. So let's write some more code. Let's go to the cat, and I'm going to take a little bit more screen real estate with this right now and add a couple of blocks to my cat's movement code. First of all, I'm going to place my cat here at the start of the maze, or the start of the level, and use a go-to block to make sure my cat always starts in that position. And then I'm going to pull this up and duplicate some of my code here and just make these last 2 arrows, the up arrow and the down arrow. And I'm going to point in direction 180 for down and 0 for up. So now when I run this, we can just see really small over here. I can run, and then eventually this banner is going to grow, but in the meantime, I can go down, I can go up, and I can run through the walls, which is going to be my next challenge to tackle. But right now I can run through, I can collect these bananas and go really fast as I collect all of them. And there we can see the first one is growing back in, the second one and the third one are now growing back in. Okay, so that's my movement. One last thing I want to do is add one more if-then statement and say if touching, and I want to ask if I'm touching these walls here, which is my sprite 1, as you can see right here. If touching sprite 1, we're going to go back to that same starting position, which was -203, 154. -203, 154. And now, when I start this, let's look full screen for a second. I can run. And my energy is going down. I'm starting to move more slowly. And when I get to these bananas, my energy will go up. And now I can move faster. And this looks a little choppy right now because I think when I run Scratch on my computer while recording these videos, it gets a little overwhelmed sometimes. But this looks pretty good. We're making our way through the level. Very good. Let me stop that and go back to normal screen. Okay, so that's my movement. Over here, I'm actually going to change this a little bit such that we always change our energy by -1. And if our energy gets less than 1, or actually, yeah, let me change this. Right now, this is our energy greater than 1. But what I really want to check is see if our energy becomes less than 1, then that's going to be the end of our game. So actually, I think I'm going to get, for this little hack, I'm going to get rid of this energy check in this speech and just replace this with, oh no, I'm out of energy. I can't go on. And after that, I'm going to use a stop all block. Okay? And get rid of some of these extra blocks. So this means that my cat is going to have to make it all the way to the end without running out of energy. So let's see if this works. And I think this should be pretty easy because but I ran into a wall. So there we see me running into a wall and going back to the beginning. So that mechanic's working. Good. And let's see if I collect this banana. Good. My energy goes up. And now I can run through the maze. Whoops. So you have to be careful not to run into the wall, which becomes a little bit harder as you move faster. But this is pretty beatable right now, okay? So that's pretty good. Maybe I'd want to shift this part up a little bit just so I have a little more room to run around down here. Okay, but this is looking pretty good. Maybe if I wanted to tweak this a little bit more, I'd go to my bananas and say this seems a little easy right now, frankly, and I'd maybe have these bananas add 3 instead of add 5, like so. And maybe I would add another sprite at the end of this, like a balloon would be pretty good actually, and this can signify kind of the end of the level. Let's see where that balloon goes here. Make that 50%. Put that down here. And we could tweak on this a little bit further and do some more, pay more attention to some of the details. But without too much hacking from our original project, we've already made this into something that's a lot more like a game that someone can actually play and win or lose, right? So I'm going to leave this webinar here. I hope you've enjoyed this, and I hope this helps you deliver this challenge to your students. And thanks for watching. Bye.